Hi there, and welcome to the first lesson in the AI and Ethics course. My name is Mr. Simpson, and today we're looking at an introduction to AI. But what is AI? AI, if you don't know already, stands for artificial intelligence, and it's a branch of computer science that aims to create smart machines. Now, these machines are just like any normal computer system, but it can learn, it can solve problems, and ultimately make decisions. If you want to think about an example of this, think about a computer program that plays chess. Um, if it's just a normal computer program, it will never learn from its mistakes, and you can beat it the same way every time. An artificially intelligent chess system will learn from its mistakes and it will try not to repeat them. And so over time, it will get better than the human players that it's up against as it learns their tactics. And there's different types of AI, and kind of narrowed it down here. So we've got two types of AI to think about. First is narrow, and that means it's good at one specific task, for example, like playing chess or creating an image. More generic or general AIs are good at many different tasks, much like humans. Okay, um, and if you think about general AI, you might have heard of something called AGI, which is Autonomous General Intelligence. Now, that does not exist yet. Okay, there are some really good advanced narrow AI systems that look like they're AGI, but they're not quite there yet. There's glitches or hallucinations that happen. But if you think about narrow AI, some examples of narrow AI are image recognition systems. So if you hold your phone up to your face and it scans your face and it lets you log into your phone, that's an example of an AI system. Okay. Um, you can also use slightly more advanced image recognition software to detect specific facial features on CCTV cameras and follow them through the town by automatically highlighting that person's head in a green square if you've seen any of those police interceptor programs that are on. You've also got language translation tools, and these are getting better all the time. Google Translate was one of the first ones, and it was in the early days, a very sort of simplistic, direct translation of an English word into a word in a different language. And now it's getting more complex and efficient because it's now looking at the entire sentence and not just translating the one word at a time. And that's why in the past your teachers used to give you in trouble when you were using Google Translate to translate something in Spanish into English, because you would miss the literal translation, or you would have the literal translation, but you'd miss the context. And so language translation tools are getting better at understanding the context and creating better better results. Another form of narrow AI is email spam filters. So these are running in the background of your Gmail or your Outlook or whatever you've got. And what they do is they look for specific heuristics or sort of rules of thumb. So if something is obviously a spam message, that message is kind of marked as spam, and that's training the model. So what is happening is it's going to look at the subject, it's going to look at where it's come from geographically, it's going to look at the content of the email message, and it's going to learn, well, what if that's spam? Are there any other emails that are coming in that look like that message, or they've come from the same address, or if they have the same title in the subject, or if they have same, grammar in the sort of message that comes in. And that's why a lot of the messages in your inbox now go into spam, because it's used what it's learned, this is spam, and then it's applying it to every message that comes in. So every email message that comes into your inbox is very quickly scanned by a spam email filter, and then if it's written by a human, or it's more likely to be written by a human, it goes into your inbox, and if it's written by a spam bot, it goes into spam. That's why sometimes you get real messages or messages from real people that accidentally go into spam, because the way it's written matches some of the characteristics of a spam email. It's an interesting field. Look out for these things in the future. In general AI, you've got an AI assistant that can switch between writing poetry, solving math problems, and then go on to design a building with human level competence. And I mean, not just my level competence, actually, trained professional competence at writing poetry and solving math problems and designing buildings. And it will do that without having to be reprogrammed or given any sort of specific complex instructions. Another future sort of goal of AGI is to create robots. Now, whether they're humanoid or sort of like the floor sweepers that you see just now, but that robot can learn any household task just by watching other humans do the same task, and then it learns from that. And so if you start seeing them, we've reached that point of AGI. In everyday life just now, AI is becoming increasingly important. We've talked about that in the previous slide. It tends to work behind the scenes, so you don't really see it happening. It's not always visible, but it's continuously learning from our behaviors. And the idea is to make your own individual experience more customized and efficient. So we've got some examples here. Your smartphone will have some AI in there, or if it's a newer one, it definitely has like a circle to search AI tool. It learns from your browsing habits, it learns what time you start to use the device, it learns how long you spend on certain apps and so on. And that can be used to give you a better experience. An example of this, is if you are like me, have hundreds of apps installed on your phone, but you only use maybe 7 or 8 of them. So after the period of maybe 3 months, your phone starts to recommend that you might want to delete these apps that you never use. And then you remember and you go, oh, of course, I meant to use that app. So that's an example of artificial intelligence where it's looking at your usage and it's giving you some suggestions about how you might improve the efficiency of your phone. Another field would be in the form of traffic management, and that is where things like Google Maps or Waze or Apple Maps starts to analyze your behavior, works out where your home is or where your place of work is, and starts to say, is this where you work? Is this where you park at night? And it will remember it, and it will employ those things when it's starting to work at your traffic, so you don't have to manually type in your home address or manually type in your work address every time. So that's an example of artificial intelligence trying to make your life slightly better. We've talked about spam filters already. And then another field where AI is trying to improve your life is in the form of movie recommendations on things like Netflix or Amazon Prime, or actual product recommendations on sites like Amazon or eBay, where and AliExpress, if you use that as well, or Wish, where based on your browsing history or your search history or your purchase history, it will rank items that you most commonly buy. Saw an advert recently from a supermarket called the Co-op, where they give you vouchers based on your previous purchases, and this is just through the app. So your weekly vouchers are AI influenced. It's similar to what other supermarkets do. I think Tesco's done it for years. They send you vouchers for money off specific items, but the Co-op is one where it's in the app. And it's updated on a weekly basis based on your previous purchase history. And I always wondered why it was always giving me adverts for Lucozade, for example, when I found out that my son was swiping my loyalty card to get a discount. And so it was using that and then recommending that I could get money off Lucozade. So there you go. There's a use of AI in everyday life. It doesn't always get it right, but it's learning from the data that it has access to. The last slide today is talking about the foundations of modern AI. And this is important because in the next few lessons, you're going to be sort of analyzing these concepts in a bit more detail and how they impact different areas. So there's 3 key concepts that work together to create an intelligent system. The first one is an algorithm. Now, this is just a computer program, or if you're not sure about computer programming, think about a recipe for making a cake, or even for making a cup of tea. Something that's a step-by-step series of instructions that allows you to solve a problem or complete a task. That's called an algorithm. You're going to learn about those as we go through. You're going to be using some of those algorithms as well. More AI related, or the field of AI, is the next 2 terms. So machine learning is kind of self-explanatory. It's where the computer system that you're using learns from data without actually having explicit instructions on how to learn. They just evolve and get better through experience. Chess and sort of AI chess systems use machine learning. So there's an example of machine learning where you just continually play the same game and the computer gets better by learning the opponent's strategies and then trying to employ them in order to achieve a goal. And the last one is a neural network. And this one is possibly, you may have heard of it before, but it's a specific type of machine learning. And the way that it works is that it's a bit like connections in our brain, and it's used to quickly recognize patterns in data and make decisions. Neural networks have been around since, I think, the 1950s. So they're not new, but they're being employed now that we have computers that are able to process so much information so quickly. Neural networks are increasing in size and complexity, and now you're seeing the benefits of that with these narrow AI systems coming through. If you want to think of an example, if you've ever done any physics or electricity, where you've got sort of two competing signals coming in to light up an LED. Okay, so if there's a power signal coming through on one channel and a power signal coming through on the other channel, then the light's going to turn on. Okay, because they're both providing power, so it's definitely going to happen. But you can add these kind of gates, and don't worry if you don't understand the idea of gates, but you've got these AND gates and OR gates, XOR gates, and so on. And neural networks are kind of similar in structure to that. So they've got lots of inputs coming into one side, and then there's a very simple decision being made in the middle, and then there's an output coming out of that. And that output is either a 0 or a 1. But because you've got a network of these things, it allows you to sort of narrow down lots and lots of competing pieces of information to either a yes or a no. And that's essentially, very kind of simplistically, how neural networks do work. So hopefully today you got a pretty good understanding of the basics of AI. You understand the different types of AI, the narrow in general. You've learned about the sort of foundations of artificial intelligence, and you've talked a little bit about how AI might be used in the real world. What I'd like you to do is, if you're in the computing class just now, we're going to be talking about it in a sort of whole class discussion. If you're using this in another subject, because you're maybe going to be creating something based on artificial intelligence and the ethics around it, then just have a think about this to yourself, or maybe have a small group discussion. It's entirely up to your teacher. But think about how you use, or you currently use, narrow AI in your daily life, because nobody has general AI just now. So we're just, how do we use narrow AI in your daily life? Thank you for watching, folks. I hope you enjoyed this, and remember to fill in the chance, sort of the opportunity for comments at the end of this video that's coming up soon. Thank you. Bye-bye.